Now, volatile substance that easily evaporate at normal temperature. These are the two things. But other, for example, you want to separate ink. Okay. Volatile from IV, so you will evaporate it and you will get it. Now, blood, everything we have done. Okay. This we already discussed everything. Right? Yes. So now today we will do this. Physical change and the chemical change. Okay. So ma'am, what is physical change and the chemical change? So physical change in shape, size, color or state of a substance. That is a physical change. Whenever you are converting something and its shape changes, color changes and its size changes, that is physical change. Okay. And chemical change, when new substance is produced with new properties. That is a chemical change. Here no new substance is formed. Change in chemical properties takes place. And over here, melting of ice, boiling of water are the examples. Burning of wood paper. So this is the first point and this is the second point. Okay. And over here they come back to its original shape, but we cannot bring back them to their original shape. This is the difference between physical change and the chemical change. Here, so writing down, your heading will be difference between physical and chemical change. First point, second point, third and fourth. First, second, third and fourth. These are the examples. These two are the examples. Okay, done.
Yes, ma'am.
Okay. Now element we have done. Okay. Okay. Now you will write alloy and you will write mixture of two or more elements or one metal or one non-metal. Then cannot be separated by physical method. Shows property of consistent and variable composition. So these are the properties of alloy. Okay, you will write it down. We're done, girls?
Yes, ma'am.
Okay. So let's just start with the question answers. Okay. So first of all, the first question is, what do you mean by the substance? Okay. So substance is a pure single form of matter. It consists of simple above particles that all consistent particles in the substance are identical in their chemical nature. It cannot be separated into other kind of matter by any physical process. Okay. Now next, so this one substance we have already written, like when we were writing the notes itself, there itself we have written it, right? The substance part, if I'm not wrong. I think we have written it. Substance, check it. Yes, pure substance, this.
Yes, ma'am.
Right? Okay, so no need to write it down. Then homogeneous and heterogeneous, we have just written one definition, so this is important. So you will write the difference. They have the uniform composition throughout the mixture, such as salt in water, sugar in water, copper, sulfate in water. They have non-uniform composition, right? The components of homogeneous mixture are not physically distinct. Okay, you cannot say in physical substance, you cannot say that this is different substance, this is other. But here they are distinct. Distinct means different. They have no visible boundaries of the separation between the consistent. They have visible boundaries of separation between the consistent. So you can write down. Question number 2, the difference.
Done, ma'am.
Okay. Now next is homogeneous and heterogeneous mixture. See, this is basically they have just written it. Differentiate between homogeneous with example. So over here they have just given you the same thing, so no need to worry about it. Just write the example over here. Salt in water, sugar in water are the example of homogeneous mixture, and mixture of sodium chloride and iron filling oil in water are example of heterogeneous mixture. Okay. Done, girls?
Done, ma'am.
Okay. Now let's just do this. How are solution and suspension different from each other? Okay. So a solution is basically a homogeneous mixture of two or more substance. SOL is basically is a heterogeneous mixture, and the suspension is basically a heterogeneous mixture. Okay. Over here, the particles of the solutions are smaller than this, and they are too small that to be individually seen by naked eyes. The particles can be seen by the naked eyes. Due to small particles, they do not scatter a beam of light. Solutions are bigger enough to scatter the beam of light passing through the dam and make its path visible. These particles of suspension scatter beam of light. The solute particles do not settle down when left undisturbed. They do not settle down when they left in the undisturbed. The solute particles settle down when the suspension is there. I think we did this. Yes, we did it. Cola, yeah, we did it, right? Suspension and everything. Okay, so no need to write it down. We already discussed this. This one is very important. To make a saturated solution, this gram of sodium chloride is dissolved in this. So over here, this is solute and this is solution. Okay, you have to find the concentration. You know what is the concentration basically, right? So this is the formula. 36 divided. You know the formula of concentration, girls?
Yes, ma'am.
So 36 multiplied by 36 divided by 136 multiplied by 100. That will give you this. So you'll quickly write this down. Okay, done. Done, girls? No? Okay, completed and let me.
Done, ma'am.
Okay. Now the question is, how will you separate a mixture containing kerosene and the petrol? Okay, the difference is this. So when are miscible with each other? So basically the process you will use, the process of distillation is used for the separation of mixture containing kerosene and petrol, since the difference in their boiling point is more than 25 degrees Celsius. Okay, so how you will do? First of all, you will take it in distillation flask and fit it with the thermometer. Then you will arrange the apparatus as shown in figure. Don't write it as shown in figure, and arrange the apparatus. And then heat the mixture slowly, keeping a slow watch on the thermometer. Petrol has a lower boiling point than kerosene, so petrol vaporizes first and the condense in the condenser, which is finally collected in the beaker. Clear? So this will
Yes.
be, you can write it.
Done, ma'am.
Okay. Now the next thing, this point, kerosene is left behind in the distilled flame. Okay. Seventh question is very, very important. Write the fifth point, then we'll discuss the seventh point.
Done, ma'am.
Okay. Now these are very, very important topic. These name the technique to separate butter from curd, salt from seawater, and camphor from salt. So centrifugation, and for salt from seawater, evaporation, and camphor from salt, sublimation. Clear?
Yes, ma'am. Done, ma'am.
Okay. Now, what type of mixture are separated by the technique of crystallization? So the crystallization method is used to purify solid from impurities. Okay. Example of crystallization as a process to separate a mixture include purification of salt that is obtained from seawater and separation of alum, which is fitkari, from the impure sample. Clear? From this chapter, there are
Yes,
high chances,
ma'am.
like 60% chances are there that you will be getting questions from separation itself. So prepare your separation part very, very carefully. Okay. Now, classify the following as the chemical and physical change. Very, very important question. Okay. So, over here, cutting of trees, melting of butter in pan, rustling of an almirah, boiling of water to form steam, passing of electric current, all this. Okay. So, these are the answers. Cutting of trees is a physical change. Why? Because once you will cut down the trees, you cannot bring that, right, to original tree. Then melting of butter in a pan, it's also a physical change, right? Because once you will melt it, now it was a solid, now it is being converted into, well, you can say thicky liquid, right? Rusting of almirah is a chemical change because see, almirah remains almirah, right? Though rust takes place, but almirah remains itself. You can call it a almirah, right? Then boiling of water to form steam, it's a physical change. Earlier it was water, now it is being converted into gaseous form. Passing of electric current through water and the water breaking down into hydrogen and oxygen gases. It's also a chemical change because it was basically water, and with the help of electric current, now you change it into hydrogen and oxygen. So totally the appearance change. So it's a chemical change. Dissolving of common salt into water, it's a physical change because earlier it was normal, but now you mix salt in it. So it's a physical change, right? Making a fruit salad with a raw, it's also a physical change because earlier, for example, your apple looked like this, right? But now physically, if you will cut it down, it will look like this, right? The pieces. Clear? Then burning of paper to wood is a chemical change because once you will burn the paper, right? And you will burn the wood. So of course they will turn into ashes. So it's a chemical process. Clear?
Yes, ma'am. Yes,
Okay, you can write it down. A, B, C.
ma'am.
Sorry, you are not audible.
Done, ma'am. Done, ma'am.
Okay. Now try segregating the things around you as a pure substance or the okay, this is not that much important. This one. So which separation technique will you apply with the separation phenomena? Again, very important. Okay. But first is sodium chloride and its solution in water. So you will use evaporation. Ammonium chloride from a mixture containing sodium chloride and the ammonium chloride. Sublimation. Small pieces of metal in engine oil of a car. Filtration. Very easy. Different pigment from the extract of flower petal. So chromatography, because color is being used over here. Butter from curd. Centrifugation. Oil from water. Separating phenol. Tea leaves from tea. Very easy. Sieving. Iron pins from sand. Magnetic separation. Wheat grains from husk. Sieving and winnowing. And fine mud particles suspended in water. Sedimentation, descension, and filtration. Clear? So these are the answers. First write the first answer, first two answer. You have your questions, I think. Okay, or if you don't have questions, first write the questions. You have your questions with you?
Yes,
Okay, so you can write the
ma'am.
answers directly.
Done, ma'am.
Okay. Now coming to the next one. Okay, this is the write the steps. Okay, not important. Okay. Hmm. You, okay, this we already done. We know saturated solution, pure substance, colloidal, and suspension already, right? Okay, so this one is important. You have to classify homogeneous and heterogeneous mixtures among this. So homogeneous mixture, which basically means they have same substance. Okay. Heterogeneous means we have different. Okay, so I'll just give you one more question. Yeah, this one. Which of the following material falls in the category of pure substance? So pure substance, first of all, you should remember the definition of pure substance, that no other substance is being matched to it, or no, it's included. Okay, so over here you can see a substance is a pure single form matter. It consists of single type of particles, although it cannot be separated. Okay, so pure substance can be classified into elements and compound. Pure substance therefore contain one kind of pure. Their composition is same throughout the evaporation. On the other hand, mixture are basically they are made. So this ice, iron, hydrochloric acid, calcium oxide, and mercury are pure substance, as they are made up of single type of particles that are identical in their chemical nature and cannot be separated into other kind of matter by any physical process. So you will write this. Clear?
Yes, ma'am.
Done.
Finished, ma'am.
Now the last one. Which of the following will show the Tyndall effect? Okay. So milk and starch solids are collides. Thus they will show Tyndall effect. Since colloidal show Tyndall effect. Okay. Only colloidal show. So this is the answer. Okay. And then the last one we'll be doing. Then I'll just leave you.